Decompose into partial fractions, 3x plus 7 over x squared plus 5x plus 6. There is a lot of factoring in this section. So if your factoring skills are bad, you will not do well in this section. So make sure you are very comfortable with factoring. We get into some ugly factoring too. You don't have to go back to your previous chapter where you have to do the P and Q thing, but your special cases as far as your difference of squares, your perfect squares and all that, sum and difference of cubes come back to say, hello. Hi. So the reason we are in this case of non-repeating linear factors is if we factored the denominator, what do we get? Yeah. So we have non-repeating, meaning that the multiplicities of all the factors is 1. Check. Linear factors, that means the degree of the individual factors is also 1. Check. Okay. Depending on the multiplicity, this tells you how many fractions you need. Since they're each a multiplicity of 1, you need 1 fraction for each factor. So one denominator has the factor of x plus 2. The other denominator has the factor of x plus 3. Comment, does it matter which one you put first? Why? Because multiplication and addition are both commutative. So the work that you do may be different, but our final answer should be the same for everyone. Okay. So that's the denominators. We now need to just figure out what goes in the numerator so that when we make a common denominator and add them together, we get our 3x plus 7. Here is the rule for the numerator, and I'll say it a couple times. The degree of the numerator, the degree of the numerator. The cabbage is on the table. The degree of the numerator, should do one of those language tapes. The degree of the numerator is 1 less than the degree of the factor in the denominator. The degree of the numerator is 1 less than the degree of the factor in the denominator. Did I say multiplicity at all? No. It has nothing to do with multiplicity. It's all about degree. So I'm referring to this magical number here that we don't write when it's a 1. What's the degree of the factor in the denominator? What's 1 less than 1? So if you have a degree of 0, what are you? You're just a number. Yeah. So we're going to call these numbers A, B. So our job is to figure out what this A and B are such that when we make a common denominator and add the fractions, we get a numerator of 3x plus 7. But that's the setup. Each factor gets its own fraction. The multiplicity tells you how many fractions you need. And again, the degree of the numerator is 1 less than the degree of the factor, not multiplicity, in the denominator. All right, now we do some algebra. This is the part of the show that students ignore. Don't ignore this. I'm about to clear out all these fractions by multiplying everything by the LCD, x plus 2, x plus 3. Mike, I'm too cool for school. I don't want to write that. That's fine. Then you also risk getting it wrong. So please, write it down. It makes it much more visual. And then in solving your rational equation, this is where you cancel common factors. So in the first one, what cancels? Yep. And you're left with 3x plus 7. The second one, what cancels? and you're left with a times the quantity, x plus 3. Now you can distribute this a through. We'll talk about that in a second. And the last one will cancels. And you're left with? Good. So the reason I'm strongly urging that you write the LCD next to each term is so that you cancel correctly. Now, there are two ways to approach this type of problem from here on out. You can pick your favorite. The one way, which we're going to start with, is really fast, but it doesn't always work. It'll work in cases 1 and 2, but not 3 and 4. The second way is a lot longer, but it definitely always works. I'll show you both. Pick your favorite. I really don't care. All right, here we go. The first way is by plugging in numbers in for x. This equation that we have on this board now is considered an identity. It's true for any replacement of the variable, trig students, variables. So you might as well pick a number for x that makes one of the other variables, a and b, disappear. So for instance, if I pick x to be -2, then I'd have 3 times -2 plus 7 equals a times -2 plus 3 plus b times -2 plus 2. Why did I pick -2? Yeah. The b term goes away because -2 plus 2 is 0 times b is 0. So basically you pick the roots. On the left, what do we get? 1 equals on the right, what do we get? A. So what does a equal? 1. Hooray. That was nice. Because it's -2 plus 3 is 1 times a is a.
Right, okay.
Is that okay? And now what other numbers should we pick for x to go back to the blue equation? -3. So again, this method, fast, does not always work. I'll show you both. You pick your favorite. Sorry, this is written so low. On the left, you get -9 plus 7, which is -2. On the right, you get b times -1, essentially, so -b. So what does that say about b? It's 2. Hooray. So your final answer here, just put your a and b over your factors that you had it. So a, which we found to be 1, goes over x plus 2, so 1 over x plus 2. Plus b, which we found to be 2, goes over its factor, x plus 3. So you partially fractioned, decomposed, why not? 3x plus 7 over x squared plus 5x plus 6. Now, this may sound weird, but is traditional if you get a negative value for a or even a fractional value for a or b, you leave the entire thing in the numerator. So, for instance, if you got a to be 2/3, you would write 2/3 over x plus 2. Why? Calc 2. They'll explain it there. All right. So let me duplicate this side real quick. Duplicate. And let's show you the other way of doing this. Eraser. Oh, Mike, yes. That's exactly what you didn't want to erase. I know. That's okay. All right. What was this, x plus 2? All right. The other way of doing it is by setting up a system of equations. So that's why this section is in this chapter, because it relates to solving a system. So the way you would do this is Distributing this a through, you would get ax plus 3a plus bx plus 2b by distributing the a and the b through. Now, if you do this enough, you'll get very comfortable with this, and you can skip right to the end, but I'll show you step by step for this one. On the right, we have two terms that have an x, so I'm going to put them together. And two terms that do not have an x, so I'm going to put those together. And notice if I factor out that x for the two terms on the right, I would get a plus b. And if I don't do anything with the other two terms on the right, I'm going to group them by putting parentheses around it. I get 3a plus 2b. The colors are intentional. What's the coefficient of x on the left? What's the coefficient of x on the right? So that gives you your first equation, a plus b equals 3. What's the constant on the left? What's the constant on the right? So that gives you your second equation, 3a plus 2b equals 7. So since that's an equation, that means your constants and your coefficients have to be the same. And that's where your system comes from. Now, from here, we know 4 ways of solving a system. You can do your substitution, your elimination, Gauss-Jordan, matrix inverse, or Kramer's rule, or I'll show you how to do it on the calculator, which is a lot faster. Mike, yeah, you could have shown us how to do that for the last test? Yeah, but you didn't have a calculator. Oh, that makes sense. Yeah, you're welcome. All right, so if you're going to go this route, what I need to see minimum is this line here, and this system. If you show me this system and then you throw it into the calculator and say A equals this, B equals that, totally fine with that. That's considered your work. The reason being is we just got through 4 sections of solving a system. It makes no sense for you to be forced to do another one. All right. So, bust out the calculator. We're basically going to have the calculator do the Gauss-Jordan command for us. This is being video recorded, so assuming there's no hiccups, just follow along. Write down the steps later if you want to. You don't have to rush now. What we need to do is we need to get this matrix into the calculator. By the way, this matrix, I don't know if I could write right here. Oh, I guess I could. Would be 1, 1, 3, 3, 2, 7. Is that okay with everyone? Okay. So to get the matrix into the calculator, you will hit second, matrix. Matrix is above your inverse. As you can see, I've been a busy boy. I've got a bunch of matrices in here. You may not have anything, which is totally fine. It's sort of inconvenient to delete a matrix. I just happen to overwrite them. So I'm going to overwrite my matrix A because I don't think I need it anymore. To put in a new matrix or to edit or to overwrite a matrix, scroll over to Edit. Pick the matrix you want. I'm going to pick matrix A here. Again, ignore all those numbers. We're going to type over them. What's the dimensions of matrix A that we need to make it, I should say? 2 by 3. We have 2 rows, 3 columns. Hit enter in between each one, or you can scroll to the right, but I think enter is a little bit easier. And now just type in your numbers going across. So 1, 1, 3, 3, 2, 7. The only bad thing about using the calculator is I cannot see how you typed it into the calculator, so please double check your numbers. Also, the calculator will only show 3 columns, so if this were a larger matrix, which we are going to experience, you'll have to scroll to get the other columns. So all we did so far is second matrix edit, we put the matrix in. All right. Now we're going to tell the calculator to use the Gauss-Jordan command. It's a couple more steps within this menu here. We're going to go to second quit. We're going to go back to second matrix. We're going to scroll over once to math. You'll notice this first one here, DET. I wonder what DET stands for. Determinant. How weird. If you scroll up, you'll notice these guys right here, row swap, row plus, star row plus, are your elementary row operations. So you could use your calculator to do those. It is good if you have fractions. I don't really stress it too much in this class. My other class where their matrices are like 5 by 10, I do tell them, please learn how to do it on the calculator. But the one we're looking for is the RREF command, which is my letter B. RREF stands for Reduced Row Echelon Form, which is fancy talk for ones on the diagonal and zeros everywhere else. So please select RREF by either hitting B or scrolling up and hitting Enter. This puts you back to the main screen. And then we got to tell it what matrix to work with. So last time, go to second matrix. Pick the matrix that you created, which was matrix A in my case. If you want to finish off your parentheses, you don't have to. And hit Enter. What do you get for A? What do you get for B? Hooray! So if you want to do the other method, which will always work using the system, totally fine. Please show me the system though.